This is the homework help video for problem 39 out of chapter 34, and it gives you a hoop of diameter 4 centimeters surrounding a solenoid of diameter 2 centimeters with 100 turns. It also gives you the length of the solenoid is 10 centimeters and that the loop has a resistance of 0.1 ohms. And it wants you to find the current in the loop at 3 different times. And the problem also gives you a graph of the current in the solenoid as a function of time. So for part A, they wanted it at t equals 0.5 seconds. So we're going to use the current in the loop is the induced EMF over R, which is the same as V over R. And EMF equals negative d phi over dt. And then d phi over dt is derivative of phi, of course, which is Ba cosine theta. And the magnetic field produced by a solenoid is given by the equation B equals mu naught Ni over L. Although in this case, all we need to know is that when you take the derivative of the B field with respect to time, that's the only one you need to take the derivative with, because the other ones are constant. The area is constant, it's just the area of the solenoid, and the angle is constant. It's going to end up being 1, because the magnetic field produced by the solenoid is parallel with the area of the hoop, with the normal from the area of the hoop. So when you take the derivative of the B field with respect to time, you get mu naught N over L times the derivative I over dt. And then to find that, you refer to your graph, and this is the current in the solenoid. So you refer to the graph and see that at 0.5 seconds, which is right about here, the slope is 0, which means that the di over dt is 0. And if di over dt is 0, dB over dt is 0, which means that d phi over dt is 0, EMF is 0, and therefore the current in the loop surrounding it, is also 0. For part B, they want it at 1.5 seconds. So you go through the same process, and you end up with this, the mu naught N over L times di over dt. And to find di over dt, it's just the slope of this graph, the current of the solenoid at 1.5 seconds. So you just find the slope. They give you that at 2 seconds it's minus 20, and at 1 second it's positive 20. So you get negative 40 for the slope. And then plug that into dB over dt, and this is what you get. And then we're going to plug that into d phi over dt. And like I was saying earlier, the cosine theta goes to 1 because of the normal being parallel to the magnetic field. And then plug in the area of the solenoid, which is the area of a circle, and make sure you use the diameter 2 centimeters divided by 2, which is 0.01 meters. So that's what you're squaring and multiplying by pi. And then EMF is negative d phi over dt. And the current is the EMF over resistance. So you just plug this all in and divide by the 0.1 ohms, and you get that the current is 160 microamps at 1.5 seconds. Part C is just like part A. They want it at 2.5 seconds. So you just see that the di over dt at 2.5 right about here is 0 because the slope is 0, and like I was saying before, that leads to a bunch of terms being 0, and it ends up that the current in the loop is 0.